Okay, so welcome to everybody there outside, and thank you for the opportunity to give a presentation about our products and about Neosid as a company. My name is Matthias Höß. I'm responsible for electronic part development at Neosid and for project management, and together with about 85 specialists, I sit here in Halver, nearly in the middle of Germany, and we produce electronic parts for different technology fields. We started with ferrite components decades ago and expanded our field of products to electronic components, and one of that was RFID transponders and RFID antennas, and we tried to minimize the size what is necessary to bring RFID transponders to very small tools and materials. A short topic overview about my presentation. I show reasons and possibilities to identification of tools, for identification of materials. I give a short overview about the product range of NeoTAG high frequency transponders. I show you some notable features about them, and I like to give some information about our competence to improve transponders and to support you. What is identification of tools? What is the reason why we do this? In different customer projects, we see transponders in tools which do life cycle management. So you can find end-of-life recognition of such tools. An example here on the right side is a hollow shank taper, or the second picture is a honing tool from the company Caria, where we made different projects together with them, and perhaps yes, other things which could be done with RFID tags in tools is predictive maintenance. There is a way to do tool tracking, so you can see where is your tool located. Is it in operation? Is it in revision? Or is it in stock? You can do cost control for tools. How long can I work with tools? How high are the costs within production per production unit? You can do digital manufacturing, so tool identification, full data link between tools and machines to work different orders from customers. You can simplify machine operation by automatic identification. There's no confusion if the right tool is used to do a dedicated process, and you can prevent tool misuse, and you can also do tool management in revision process. So altogether, you can use the RFID transponders in mechanical tools for smart tool operation. Another possibility using RFID tags, NeoTAGs, is the identification of materials. So you can do inventory identification. An automatic reading process is used for recognition of them. You can do product traceability, give material consumption control, and also material misuse prevention. Load box identification is also possible, so altogether a shop floor management in production areas. Digital manufacturing is a result of it, and other things which also come together with it is, for example, counterfeit protection. Another field of use is the equipment inspection, especially for chains and hoses. You see it on a picture where special transponder is used to do this. The product range of Neosid RFID transponders, we have different types of transponders. The one on the left side is called the inlay. That's where the transponder, how the transponder is produced. So we have a special ferrite core and a small RFID IC is placed on it, and we wind directly on the ferrite core to build up the antenna for the RFID tag. We call this type of transponder an inlay. Another version is the long inlay, where you can get bigger reading distances. This inlay is used for different other shapes of transponders in our product range. One is an 8mm version. So the diameter is 8mm and the small inlay is placed inside. We have a 4mm version and a new transponder which only has 3mm in diameter size. So it's quite small to identify very small objects. On the right side, we have 3 transponders which all include the longer inlay. And with this versions of transponders, you can do NFC reading possibility with normal mobile phones. The third design is called a flag version. A flag version is always used when there is no possibility to drill a hole inside the object. And for that case, you can fasten it with a cable tie and change it, for example, for yearly changing services. All of them, the complete range, we have available in metal and non-metal versions. So they are specially tuned to work in metallic and non-metallic environment. Some product highlights which are new in our product range. One of them is the new 3mm transponder version. It has only a diameter of 3mm. It has an area reduced by 40% in comparison to the 4mm version, and the tag volume is reduced by nearly 50% in comparison to that transponder. We produce it with a high quality standard with a 100% outgoing inspection. We can offer up to 2528 bit of user memory. The plastic housing and the IC, so the complete transponder, is usable for up to 180 degrees Celsius for 50 minutes, and we can change the design to customer demand. The housing is patent protected, so we have special shapes to hold the transponder in a proper way in the drill hole. This transponder works with 200 milliwatt readers, so there's only a small power needed to read this transponder. Another product which is quite new is the 10 millimeter version. In many machine tools in the industry, we have a 10 millimeter hole included, so this transponder fits directly into such holes, and it makes the tool to get a smart tool. We have best reading distances even in metallic environment, and this tag is an NFC Forum Type 5 tag. It is possible to read it with a mobile end device. The third product which I like to announce as a highlight is the new flag version. I've shown the small flag version in one of the former slides. This one includes the long inlay, which offers readability with mobile end devices. You can fasten it with cable ties or comparable fastening solutions, stranded wires or round wires. It is from the plastic housing, a reliable plastic part. Is for industrial use. It is reusable if you change the cable tile, and also offers readability with mobile device, as I said before, and it is an NFC Forum Type 5 tag. What are notable features of these transponders? I like to give some technical details about them. We can offer them in different front logos according the customer wishes. We can change the plastic housing color according to RAL colors. We can change the plastic housing material if necessary, for example, for FDA, food industry, and other areas. The antenna adjustment is possible to bring the antenna of the transponder to the correct working frequency, because the environment has a big influence to the ferrite-based antenna inside. An often question of customers is, how do the transponders work on high temperature? So there is a limiting value, which is the data retention time of the IC, and we checked and tested our transponders to give a lifetime estimation for higher temperatures. To compare metallic and non-metallic environment, we show here a simulation comparison. Here you can see that even if you bring the transponder back to the right center frequency, you get less magnetic strength outside the object, so only to show that reading distance is much smaller in metallic environment in comparison to non-metallic. Why is it? Why do we have such a problem? Well, the metallic environment changes the electromagnetic behavior of the complete transponder. So the metallic environment moves the working or resonance frequency to higher frequencies. So it's necessary to pre-tune the transponder to a lower frequency level to bring it back to the center frequency of 13.56 megahertz inside the metallic environment. In addition to this, some competence fields of Neosid. We are a specialist in ferrite core production in special shapes where we use injection molding technology to bring a ferrite core to a special shape. For example, here we have different electronic parts. One is a cube, 3D cube antenna, where we have a hollow one-piece ferrite core. The advantage is that we can wind a copper wire directly on the ferrite core. We don't have any additional materials, which has the advantage that we get high Q values and have a high sensitivity. And because of the hollow cores, we get a low weight by in combination with a good and high performance. To show miniaturization, I show you some pictures of the inlay transponders which we produce, and beside that you can see some pod cores which have a quite small shape and have very accurate mechanical form. The wall thickness goes down to 0.2 millimeter, and the minimum volume we can work with is 1 cubic millimeter. The high dimension tolerances we can do with injection molding go down to ±1%. We use this technology not only for ferrite cores for transponders, but also for SMD transponder coils, which are used in the electronic industry and also for RFID antennas. Because the ferrite core is only consisting of one part, we have very good vibration and drop performance, which is an advantage, especially in the automotive environment. Some customer success stories are, for example, the IoT operation with an smartwatch, wristwatch. The RFID transponder is programmed, and the end customer is possible to read the content and have direct access to a web page. In this case, it's with the company Werenbach from Switzerland, and they offer a live stream view from the ISS to the Earth. Another example is honing tool management, what I mentioned before. The company Cadia included our 4mm transponder to realize errorless identification of tools. They transfer tool-specific data stored in the transponder up to the control system. They work in very harsh environment in the production line and offer consistently static evaluation, and this is a good example for Industry 4.0. What we offer is the complete development process with in-house development of RFID and NFC solution and customer-related products. We can do magnetic simulation for different customer applications. We have an in-house test lab where we can test the transponder in the application. We do in-house production machine development. And one advantage is also that we have a local raw material sourcing in the European area. We do 100% testing of all series produced parts, and we have an ISO 9001 and ISO 14001 certified production and development. We can offer small production batches and also large quantity production with our production daughter in Poland. So that was a short overview about our RFID high frequency transponder and specially used in Industry 4.0 applications.
Yeah, Mr. Höß, thank you very much for your presentation, for the technology insights as well as the use case insights. Thank you very much for that. And there are some questions for you. Is it okay then that we address those questions after the next presentation, so we have the chance to stay a little bit in the time frame? Is it okay? Will you be there?
That's okay. That's okay. I stay in the line and they can ask me afterwards.
Perfect.
Okay.
Yeah, the first question is, I think it was in your presentation, but maybe it's good to have your answer on this question. To what case scenarios does the NeoTAG require a maximum temperature of 180 degrees?
I have to look to the data sheet. We give some information, especially for that temperature.
Mm-hmm.
The best way is to have access to our webpage, and we give detailed information in the data sheet of this part. And I think there you can read everything about high temperature behavior.
Okay. Yeah, there's another question related to this topic. That's a little bit extreme. Any transponder that resists up to 900 degrees Celsius of temperature?
Not in our product range. I don't know transponder active, or let me say IC-based transponders which work up to that high temperatures.